Alright, so 3.5, today we're going to focus on finding the real roots of polynomial equations. Later this week we will find imaginary roots, so we'll find all the roots of polynomial equations. Today our focus is on real roots. Okay, so identify the multiplicity of roots. That's going to be something new we're going to talk about. And then we're also going to solve by factoring. So this is going to flow nicely from what we did last week. If you are solving by factoring, you have to get all the terms to one side and set them equal to 0. And then in terms of factoring, what are some things that you guys have trouble remembering? You don't have to write it below. Let's talk about some of the things. And then what we're going to write below are the different steps. Well, what is the first step? Yeah.
I just had trouble simplifying it all the way.
Okay, so yes, completely factoring. We're going to talk about that. Yeah, and when you do have to simplify it all the way, the first thing that we do is something you have to look for when you're factoring by grouping. What should always be the first thing that you are doing in your factoring process?
Find the greatest common factor.
Yeah, find the greatest common factor. So take out the GCF, take out the common factor, okay? And then once you take out the GCF, what's the next thing that you want to do? Look for special patterns. Let's talk about what special patterns we have. What are some of the special patterns? Perfect, the difference of two squares. We also have perfect square trinomials. What did we learn last week? Yes, the sum and difference of two cubes. And then really, even we can throw under there the 4 terms. That's special, right? Because you can do the grouping only if you have 4 terms, right? And I think some of us have trouble guessing and checking with FOIL. The last step, the trinomial, especially if that first value is not 1, that throws people off. But remember, it's always the first 2 terms multiply to the first term, the last 2 terms multiply to the last term in the trinomial, and then when you FOIL, you combine like terms that should add up to the middle value. Okay, so we are going to be practicing that today as well. Okay, so you take out the common factors, you look for that GCF, you look for those special patterns, the difference of squares, sum and difference of cubes. There are 4 terms, you group the first 2, group the second 2, look for what they have in common. Okay, if you don't have those special patterns, you are going to be guessing and checking with FOIL. We're going to do a little bit of, well, actually not all of those, but a few of them. Okay, so for example 1, it says to solve each polynomial by factoring. And then when you are solving by factoring, you do have to factor completely. So that means if you, like for example, if you did the factoring by grouping, you would have to make sure that you broke it down all the way. You couldn't have like the difference of 2 cubes or the difference of 2 squares. You'd have to break that down. All right, and then let's try part A together. Okay, so again, when it says factoring, we have to factor completely. We'll go over some examples of that, of what to watch out for. Okay, so for part A, we have 4x to the 6th plus 4x to the 5th minus 24x to the 4th equals 0. So we already have everything on one side. I want you to go ahead and factor. Okay, factor all the way. And again, start with your first step. So is there something you can take out of all of those values? to look at the number and you have to look at the variable. Okay, so we're going to take out 4x to the 4th. Okay, and then, Rashawn, can you tell me what will be left inside if I take out 4x to the 4th?
X squared plus x minus 6.
Good. Okay, so when you're doing this, you're dividing. 4x to the 6 divided by 4x to the 4th is going to be x squared. You could also think of it as distribution. 4x to the 4th times x is 4x to the 5th. 4 times negative 6 is the negative 24, and then you have the x to the 4th. Okay, you don't have any special patterns here, but you do have to see if you can factor the trinomial. See if you can guess and check with FOIL. Okay, this one really isn't so bad because if it's x squared, you start with x and x, and then the last two numbers have to do what? Okay, so if you have a negative 6, what does that tell you about the signs?
Plus and minus.
Yes, plus and minus. So it's either 1 and 6 or 2 and 3. Okay, it has to add the positive 1, which makes this what? X plus what? 3, and then x minus 2. Okay, now for the next step, this is the step that some of you like to skip, but we're not going to skip. We have to use a special property to solve. Do you guys remember what it's called? There's a special property that we use to solve this. So what is my next step? So I want to find the values for x. What can I do? No. What have we done? We've done this before. We just didn't have this many factors. Yeah. Yeah, we're going to set them equal to 0. Why can we do that? Why?
Because it was already equal to 0.
Yeah, but what's a special rule that we know? Because these are all being multiplied, right? Mm-hmm.
One of them must be 0 to equal 0.
Yeah, one of them has to be 0 if they multiply to 0. So we're going to use what's called the 0 product property. Okay, so we're going to use that to solve. So when you do that, you have to set each factor equal to 0. This is a factor. So we have to set 4x to the 4th equal to 0 and solve. This is a factor. So we have to set x plus 3 equal to 0 and solve. And this is a factor. X minus 2 equals 0 and solve. Okay, now these few are pretty quick. Add 2, add 2. Subtract 3 from both sides. Okay, and then the last one, you would divide both sides by 4. And you have x to the 4th equals 0. Do you guys know how to undo the 4th power? Well, you kind of, yeah. So why did you say square root and then square root it again?
Because square root of 2 and 6 plus 2 equals 4.
So if you took the square root, you get x squared, then you have to do it again. Why don't we just do it once and take the 4th root? I know, that's what I'm showing you. Okay, so yeah, so just like with x squared, you take the square root. If it's to the 4th power, you take the 4th root. If it's to the 3rd power, you take the 3rd root. And then remember, when you are taking this root, if it's an even root, you do want to put the plus or minus. But because it is 0, okay, because it is 0, you don't have to include that. But today we're going to learn about multiplicities. And when you take the 4th root of 0, your final answer is going to be x equals 0 with a multiplicity of 4, which I know is a little bit different. and then what we're going to do is we're going to write out all of our zeros together. Okay, and then after we do all of these parts, we're going to talk about a special pattern that happens. So the zeros are -3, 2, and 0 with a multiplicity, and you guys can abbreviate it like this, of 4. Okay, and then you guys can start on part B, which is x to the 4th plus 25 equals 26x squared. Okay, so think about what your first step is and then how you're going to proceed from there. Remember, we wrote down what our first step is, right? What's the first thing we want to do? That's after you do this part. Yeah, move everything to one side so it's equal to 0. Once you move everything to one side, start to see if there's a special pattern. It looks like we have some perfect squares there. But if it's a trinomial, you can always try to guess and check, right? It's just this one is x to the 4th. So when you're trying to simplify the trinomial, you have to start each parenthesis with what? So first things first, we move this over. When you guys move this over, did you write it in standard form? Okay, good. So x to the 4th minus 26 x squared plus 25 equals 0. Okay, so there's no GCF. There's nothing I can take out of all of them. There's no special pattern, but I do recognize I have a perfect square here. So I'm going to try to factor. All right, well, if it's x to the 4th, what can I split that up into? Yeah, x squared and x squared. Plus a big hint is that, see how the middle is x squared? So you're going to want to split it up like that. And then the last two, Cooper, what do the last two have to multiply to? Yeah, so I can make my little chart, right? To get 25, it's either 1 and 25 and 5 and 5. If it has to add to negative 26, which one do I have to use? 1 and 25. And then look at the sign. This is a negative, which means that both of these have to be negative in order to multiply to positive 25 and add to negative 26. And this is where the factoring completely comes in. So you can break these down again, so you need to do that if the directions tell you to factor. Okay? If not, you could just set those equal to 0 and solve. But if you're factoring completely, you have to use the difference of two squares. Okay? So Aiden, what does x squared minus 1 break down into? Mm-hmm.
X plus 1, x minus 1.
Yeah. Okay, and then Dane, what does this one break down into?
Negative 1. X minus 5.
X minus 5, and the other one has to be?
Oh, plus 5.
Yes. Yep. So the difference, because one will be negative, one will be positive, and that will make the middle cancel out. And now we can set each of them equal to 0. Okay, so x plus 1 equals 0, x minus 1 equals 0. X minus 5 equals 0. X plus 5 equals 0. So I'll get x equals negative 1, x equals positive 1, x equals 5, and x equals negative 5. The order of those doesn't matter. If you put the plus first, that's fine. If you put the minus first, that's fine. And then usually when you list the zeros, you put them in order. So it would be negative 5, negative 1, 1 and 5. It's not a big deal if you didn't. Okay, we just want to see those 4 there. All right. And part C is x to the third minus 2x squared minus 25x equals negative 50. Okay, so I want you to see if you can factor that. Okay, so you do have a special pattern for this. What is it? What's the special method you have to use? Grouping. And then when you move over that 50, make sure that you add it over, because it should be plus 50. Sometimes people just move it over and then they forget. Okay, so we group the first two, we group the second two. Ava, what did you take out of these two?
I took out x squared.
Good. So then you should be left with x minus 2. And then here you would take out negative 25, so you would also be left with x minus 2. Remember, you have to have the same factor in both of them in order for you to factor by grouping. And then once you do, you have x squared minus 25, x minus 2. This is where we have to remember, again, you have to check for those special patterns. Because x squared minus 25, we just did this one. What should that factor into? Yep, x plus 5 and x minus 5, and then you have the x minus 2. Okay, so then we're going to set each of the factors equal to 0. Okay, and then we are going to label our zeros. Okay, so our zeros for this one are negative 5, 2, and 5. Okay, so there is a special pattern, there's a special rule for the number of zeros for a polynomial. Okay, we're going to write it right here. The number of zeros for a polynomial is equal to, yeah, what is it?
Highest exponent.
Yes, which is the degree. Okay, so it's equal to the highest exponent or the degree of the polynomial. Alright, let's see if he's right. Hopefully yes, because we wrote it down. So let's check it. We'll start with C. Okay, what's the degree for C? 3. So if the degree is 3, there should be 3 zeros. Do we have 3 zeros? Yes. Alright, so that one checks. Let's look at B. Okay, so how many zeros do we have for B? 4. Is that the same as the degree? Yep. That one checked. Yeah, now A is kind of funky, right? Okay, so what's the degree for A? Okay, so the degree is 6. Are there 6 zeros?
Yes.
Yeah. Do you guys know why?
Because it's the multiplicity.
Because of the multiplicity. So if the multiplicity is 4, that 0 counts 4 times. Okay, so there are 6 zeros there. 1, 2, and then this counts 4 times for a total of 6. Okay? So the multiplicity does factor into the total number of zeros. This is something that we're going to be using over and over again this week. Okay, so recognizing the degree is the same as the number of zeros. And we can also use it with a graph. So we are going to be using graphs today as well, and that's what we're going to talk about on the second page. You guys ready? All right, so with multiplicities, the first thing we have to talk about is what is a multiple root. It is just a root that appears more than once. A root that appears more than once. And we're going to go over some examples. Okay, so one example of a multiple root would be like if you have 3x cubed equals 0. This is very similar to one that we had on the front page. And then if you have x to the third, you guys remember what kind of root I said you'd use? Yeah, cube root. So you take the cube root of both sides. And then this situation would be x equals 0 with a multiplicity of 3, because we took the cube root. There are other situations too, and situations, so here's one example, here's another example. We briefly talked about this, but we're going to go into more in depth now. So if you had something like x squared plus 8x plus 16 equals 0, let's solve that one by factoring. So I need two values that are going to multiply to 16 but add to 8. Yeah, this is one of our perfect square trinomials, right? Okay, so if you had x plus 4 equals 0, and you got x equals negative 4, and then x plus 4 equals 0 here, x equals negative 4. This is where you would say x equals negative 4 with a multiplicity of 2. So it isn't just going to be 0 all the time. Was there another way you guys were thinking you could solve this part? Because we did this a few times. Yeah.
How do you get like 2? Like,
Because it just happened twice.
oh,
So it's the multiplicity of 2. So one's here and one's here. You could also think of this as x plus 4 squared, right? Remember we did this a lot? Take the square root of both sides. And what you would just have to remember here is because you have the plus or minus, even though it does not affect the 0, you would have 0 minus 4 and negative 0 minus 4. And again, it would be the same answer. X equals negative 4 with a multiplicity of 2, because these count as two different solutions. Okay, so that would work as well. Okay, so when you are talking about the multiplicity of a root, it's just the number of times that it is a root or a factor. Okay, so the multiplicity of a root is the number of times the root is a 0 or a factor. Okay, which you can see here. The negative 4 happens twice. That's why the multiplicity is 2. Here you take the cube root. Multiplicity is 3. Okay, and you can solve by algebra, and you can look at certain situations where you have the plus or minus, but you can also look at the graph. So that's what we're going to talk about next, is how you can look at the graph and find these even and odd multiplicities. Okay, so there's a special rule for even multiplicities and a special rule for odd multiplicities. So if a multiplicity is even, the graph touches the x-axis but does not cross it. Okay, you'll hear me call that a touchback because it touches it and then goes right back in the direction that it came from. And there are a couple different ways this can happen. We're going to draw some examples. I'm going to draw just some sketches. So here's your y, here's your x. I'm going to draw both of them out. Okay, so the graph touches the x-axis but does not cross it. You can watch me draw it and then you can draw it yourself. So it could look something like this. Okay, so where it touches it here but it does not cross, that is what makes it even. It's where it touches the axis but it doesn't cross it there. It could also look something like this. Again, it's something where it touches it and then goes back, and that means there's an even multiplicity at that point. Do you guys remember me mentioning that when we were doing parabolas? It was very brief. When we were doing parabolas, like it touched it when it was right on the x-axis. That's when we had the same one, because we talked about how it had 2. And then the second one is odd. Okay, and it says odd and greater than 1. So what that means is your degree would have to be 3, 5, 7, so on and so forth. It can't be 1, because if it was 1, what would the graph look like? Yeah, it just looks like a line, right? Wouldn't it just be linear, x to the first? Yeah, okay. If it's even, then the lowest degree it could be would be what? 2. So this could be 2, 4, 6, so on and so forth. Okay, so if it is odd, then the graph bends. Okay, bends as it crosses the x-axis. That's where it will bend. Okay, the graph bends as it crosses the x-axis. Okay, and we've seen this before, mainly with our cubic functions. So let's draw an example of that. Here's our y, here's our x. Okay, so it could look something like this. Okay, and the part where it bends is right here. So this means there's an odd multiplicity right there. And the odd multiplicity is only right there. Okay, it's only where it bends across the axis. Okay, if it doesn't have that special thing, and you can see this here, see how it just crosses straight through at this point? That means there's just 1 0. So there's 1 0 here, 1 0 here. If there's a bend, it has to be an odd multiplicity. This one goes straight through, there's just 1 0 there. This one goes straight through, there's 1 0 here, 1 0 here. Okay, so what we're going to do is we're going to find the number of zeros. Well, actually, we'll do this example and we'll come back and we'll talk about the degrees that could be associated with them. So for example 2, it says to identify the roots of each equation. And then we're going to state the multiplicity of each root. Okay? And then if the multiplicity is 1, you don't have to state that. You can if you want to. You don't have to though. So for A, we have x to the third plus 6x squared plus 12x plus 8 equals 0. Okay, so recall, just from a little bit ago, how do you know how many zeros an equation has?
The degree.
Yeah, it's the same as the degree, so we're just going to write that down. Same as the degree. So how many zeros does this have? 3. So that's going to be useful when we're determining what the multiplicity is. So we're going to sketch the graph with our graphing calculator. Okay? If we're doing something in our notes, it's something that you're going to have to do on your homework. Okay, so if it says sketch the graph, okay, for these you are going to have to just do a sketch. And a sketch means you don't have to put the specific points on there. Okay, it could be a little bit of a rougher sketch. Alright, so let's put this equation in. So we have x to the third. So x to the third power plus 6x squared plus 12x plus 8 and then I'm going to put my window back to the standard window, so zoom standard. Yours might already be in there. Okay, so what does this look like it has? A bend or a touchback? No, because it goes through it. Right? If it touches back, it touches it, and then it'll go back in the same direction. Okay, so let's draw our sketch of it. So mine looks like it bends right here and then continues to go up. Okay, and then we are going to use our calc function to find the zeros. So you go second, trace is what you're going to press. Those are the buttons. So second, trace, and then we're going to use this to find the zero. So let's go to 2, and then this is very similar to your min and your max. It'll ask you the left bound. So I'm going to go to my 0, or close to my 0, and then I'm going to go a couple to the left, and then it's going to ask me right bound, and I'm going to go a couple to the right, and then I'm going to try to get this right on my 0. Remember that when you're trying to get this right on your 0, for every single x-intercept, which is what we're finding, what do we know? Every x-intercept has what? It has y equals 0. So I'm going to try to get as close to that as possible. Okay, and then look, sometimes you'll have negative 2, sometimes you'll have negative 2.000, sometimes it'll be negative 1.99999, and you'll have to round it up. So your 0 here is what? Negative 2. Did some of you get negative 2 exactly? If you have like the flat calculators, you may have gotten that. Okay, so your 0 is negative 2. So I might even just add to my sketch that this is negative 2 here to show that it's bending through there. Okay, so your 0 is negative 2, and it only crosses the x-axis how many times? Once. Okay, so when I say like analyze the graph here, those are things that you want to look at, right? It crosses the x-axis once. And keep in mind that you know that, oh, yeah, remember what we were doing last week? That's what I wanted to remind you of. Remember what you just did on your test? Yeah, you had to describe the graph, and then you had to tell me what the real zeros were and how you knew how many real zeros there were. Right? So how many real zeros are here? Okay, and how did you know it? Okay, because there are 3 x-intercepts, right? Okay, so this is a little bit different. We didn't have multiplicities in the ones that we were doing before. Now we have multiplicities. Okay, so it only crosses it once, but that doesn't mean there's one real 0. That means we have to analyze using the multiplicity how many times they're there. Okay, so when you're analyzing the graph, you have to take into account the multiplicities. So I asked, does it touch the x-axis but doesn't cross, or does it bend as it crosses? It bends. We talked about that, right? So it bends. Okay, and then the how do you know, we're going to talk about the degree, okay? So the degree of this is 3. So the degree is odd. So there should be an odd multiplicity if the graph crosses the x-axis once. So the number of times it crosses the x-axis is going to be important. Okay, so the degree is odd, so there should be an odd multiplicity if the graph crosses the x-axis once. So the root is negative 2. What's the multiplicity? What's the multiplicity? Yeah, multiplicity is 3. Because you have to have 3 total zeros, right? Okay, if the degree was 7, okay, then this would be -2 with a multiplicity of 7. So the degree is tied to the multiplicity. Okay, sometimes they're split up, so we're going to look at a different example. So for B, we have x to the 4th plus 8x cubed plus 18x squared minus 27 equals 0. And just FYI, the multiplicity does not always match the degree. This one did. Okay, so we're going to check and see what happens with this one. All right, so let's graph it, and then I want you to draw the sketch. Oh, I'll show you how to do something new on your calculator. If you want to not type all that over, you can go to second, INS means insert, and you could insert x to the 4th. I think I need to insert a plus. Or you could just start all over again too. But okay, so x to the 4th plus 8x cubed plus 18x squared, and this means delete, so you can delete that. Okay, now we're going to graph it. Okay, so see how you can't see what's happening at the bottom here? So we're just going to extend that down. And you could try a few things. Do some of you use the zoom in and zoom out? Yeah, sometimes when I use the zoom out, it's too much. So like if I use the zoom out, let's see what happens. So zoom out is 3. Okay, so that's a lot of zooming out. I don't like that. So I'm going to go back to my standard. Well, actually, I'm going to go to my window. And then really, I just want to see what's happening down here. So I'm going to go to my window, and then maybe instead of -10, I try -20. And maybe my scale, I'll go by 2s. So let's see if that's enough. Nope, still not enough. So let's go to what? -30? All right. Okay. All right. Yeah, now I can see it. Okay. Now, when you're looking at mine, it looks kind of jagged, right? The graph is not really jagged, but why does it look like that? Yeah, it's the pixels on the calculator. Okay. So when you're doing that, when you're doing this. And if you have one of the flat back calculators, you'll see that yours looks smoother than mine does. Okay, and then we're going to draw a rough sketch. I can tell this one. Where is this going through? That looks like 1. And then this looks like 1, 2, -3, it looks like that's where it's bending. I'm going to verify that. But I am going to put the bend in there. And then this thing going up here. Okay, so like I said, we're just doing a sketch. It doesn't have to be perfect. It should get the general shape. Okay, and then we'll check and make sure that those are at those points. So I'll model that for you again. You're going to go to second, and then it's the trace button because calc's above it, and then we're going to find the 0. So we're going to do this twice for this one. So I'm going to try to get as close to the 0 as possible. I can't get very close to it with this one. So the left bound is going to have to be here, the right bound is going to have to be there, and I'm going to have to guess at the same spot. But look, it gives me the 0. So that is at 1. which is what we predicted, right? Now look at the graph. Is there a bend here or a touchback? No, there's no bend, there's no touchback, which means this is just x equals 1. Okay, and this is only 1, 0. If there's no bend or no touchback, it is just the multiplicity of 1, which you don't have to state that. Okay, it's just 1, 0 is there. Okay, now for this one, what's happening there? Is it a bend or a touchback? It's a bend. So I know that my multiplicity has to be odd, and so I'm going to use my degree to help me. So left bound, I'm going to go close to my 0. Right bound, close to my 0, and then I'll guess right on it. Okay, and this is another one where I'm just rounding. So we said that looked like -3, we were right. Now in order to find the multiplicity, first it's a bend. Okay, so we know it's an odd multiplicity. So this is x equals -3. It's an odd multiplicity. So the total number of zeros is how many? 4, because that's the degree, right? So if this is only one of them, how many does this have to be? 3. It all depends on the degree here. Okay, so the way that you would write your answer is that your zeros are 1 and -3 with a multiplicity of 3. Notice that for this one, your multiplicity does not match the degree. And look, the multiplicity is odd, but your degree is even, so don't get those two messed up. All right, we're gonna try this with a couple more pictures, okay? So that you can just see some different examples. So I'm going to give you a picture, I'm going to give you a degree, and then we're going to try to figure out what the multiplicities are, okay? All right, we're going to start with this one. Okay, so the degree is 7. Okay, we'll say this is at 4, we'll say this is at -2. Yeah, what would the multiplicity be at -2? Why? Okay, so this has to be 1, 0, right? If this is 1, 0 and you have to go to 7, this has to be the multiplicity of 6. Okay, if the degree was 5, then this would be the multiplicity of 4. So you have to know what the total zeros are. Okay, what about this one? Then we'll do one more. I'll put numbers on there. Say this is 3, and let's say this is -3. The degree is 5. Yeah?
And for -3, it's 3.
Yeah? Because the multiplicities together should add up to what?
5.
The degree. Okay, let's do one more. I guess we'll do these 2 and -2 as well. Okay. Oh, and the degree, let's make it 6. Oh, just kidding, I can't do that. I know. Let's make it 8. 4 and 4. Why couldn't the degree be 6?
Because then, if you go to even if you 3 and 3, but it's a bend back, so you can't be odd.
Exactly. They can't be odd. So this is a touchback, so it has to be a degree of either 2, 4, 6, 8. If the degree is 8, you have to split them evenly. Okay. Well, really, this one could have multiple answers. Couldn't this one be 2 and this one be 6? Yeah, you won't have one that's like that. It would be 4. Okay, so for your homework, which remember I said the next few days are pretty intense, so I would make sure that you're doing your homework.
Is this due tonight or is it due like tomorrow?